All right, so we've talked about functions as equations. We're now going to talk about function notation. So equations that represent functions are often written in function notation form. Well, what does that mean? That's kind of like the grown-up language or the grown-up phrasing for a function so that we don't always say y equals. Sometimes we want to give that function a name. Sometimes we'll give you multiple functions at once so that if we give the function a name, that can help us differentiate between the rules, okay? So the way that I represent a function notation, if I have this normal equation, y is equal to 4x minus 1, and I'm going to write it this way. I'm going to put f, and then in parentheses, I'm going to put x, and that's going to be equal to 4x minus 1. So all I did was I replaced the y with this f parentheses x. Now we read this as f of x equals. Okay, that's how we read that. The f of x, that is the output, and the x is the input. Okay? Now, let's look at our first example. I give you this function notation, and it's especially useful for finding a value in a range that corresponds with a certain domain value. Now, normally, if I were to look at this, I would give you the equation where it would look like this. I would say y is equal to 4x minus 1, and then I would tell you x is equal to negative 7, okay? And you would plug this in, okay? So I would say y is equal to 4 times negative 7 minus 1, which give you y is equal to negative 7 times 4 is going to give you 28, negative 28, minus 1 is going to give you negative 29, okay? So we know how to do that. That's fine. We've used this method. But I'm going to use the method using function notation. The only difference is instead of the y, I'm putting f of x, and then instead of saying f x equals, I'm saying f of negative 7. When I say f of negative 7, I'm saying the x is equal to negative 7. So let me write this. Same as x is equal to negative 7. Okay, that's telling me that that's my input. Now the way that I would write this is then I would say f of negative 7 is equal to, I'm replacing the f of x now with f of negative 7, or rather I'm replacing the x with my input. So then now I'm going to say 4 times negative 7 minus 1. That's then going to simplify. I'm only going to simplify the right side. I'm not solving for anything on the left side. The left side's already solved. We've solved for that y value. Now once we simplify the right side, that's going to give us what that y value is. So that's going to be the negative 29. Now what makes using function notation powerful is if I look at this equation, so if I look at that final result versus this final result, okay, this function notation result tells you everything you need to know. It tells you that the negative 7 is your input and the whole of negative 29 is your output. While here, if I look at this final result without using function notation, I only know that y is equal to negative 29. I don't really know what my input was. I have to look at the entirety of all of the information given in order for me to know what my output was, or my input was. All right? And that's all we're doing on most of these. So let's do a couple together. I'm going to do a really easy one for you, and then I'll do a hard one to discuss it. So we're looking here for this one, f of 5. So I'm going to say f of 5 is going to be equal to, replacing the x with 5 plus 7. That's going to give me f of 5 is equal to 12. And we're done. That's all we're doing on these. Now let's do one with fractions. So we've got h of x, and notice that this is a different, instead of f, I have h. All that is representing the name of the function. So I'm going to say h of 9 is going to be equal to 2/3 times 9 minus 1. Okay, 9 divided by 3 becomes 3, so that becomes 2 times 3, which is going to give me 6 minus 1. So h of 9 is going to be equal to 5. And we can also use our calculator for this. So if I want to do number 8, now these are our absolute value notations, and I'm going to show you on my calculator how to find absolute value on my calculator. So I'm going to go to y equals, and I'm going to clear my fraction. And I'm going to go to this button right here that says math. And then over here at the top, you see math, number, complex, probability, fraction. Okay? We want to go to the one that says number. And that number 1, it says ABS. That ABS stands for absolute value. Now, as you can see, it gave me the bars in between. So that's going to be x minus x squared, and I'm going to use the caret over here to the right to make it go up, and then I'm done. I'm going to go to second graph to get my table list of values. Now we wanted to know where we've got g of -7, g of -7, so I'm going to go down to -7. That's going to give me 56. Now, just in terms of talking about you solving this algebraically, this would be g of -7 is equal to absolute value, -7 minus parentheses -7 squared. Notice I kept this negative, and that negative is outside the parentheses. That means that negative doesn't belong to that exponent squared, okay? So that's all going to stay when I rewrite this. So this would be absolute value, -7 minus. Now I'm going to evaluate -7 squared. -7 squared is +49. Now, since that negative was there, it becomes -49. This is then going to be equal to -56, absolute value. Absolute value means that we're looking at the absolute distance, which gives me 56 positive value, which is what we got on the calculator. All right, I will see you in the next video where I will talk about some other example problems.